Vectors are one of the new topics that were brought into this course at this standard when it changed from credit to National 5. And you can see why, because they're one of the fundamental parts of the higher course. So looking at progression, getting the basic skills nailed now actually works better for you when you take on the course next session. Now there's several key characteristics about a vector you have to calculate, one of the most important of which is the magnitude. Now, when you're thinking of the magnitude, it refers to one element of the vector, and that's the size. If you're thinking of that in terms of a straight line, that's the distance that the line covers. So it would be the distance the vector covers in this three-dimensional or two-dimensional space. In this case, the vector p is a three-dimensional vector. It's got an x, a y, and a z component. Now, to calculate the magnitude of the vector, what we have to make sure we do is square each element within the vector itself, add them together, and then take the square root of that answer. So to get the magnitude of p, what I have to do is take the square root of, in this case, 6 squared plus 27 squared plus the negative 18 squared. Now, because we're squaring each element, even though this is a negative here, what will happen is that the negative will cancel itself out and we'll end up with positive values all the way along. So when we take each of the elements and square them, 6 squared is 36, 27 squared, well that's plus 729, and then it's plus negative 18 squared, 18 squared quite simply gives me 324. So I'm going to add each of these bits together, and then I'm going to take the square root of the overall answer. So if I add each of these things together, I end up getting the square root of 1089. And the square root of 1089, which then gives me the magnitude of p, is equal to 33. So my vector p is a magnitude, i.e. a length if you were to plot it in three-dimensional space, of 33 units. We have to be able to do this in order to then be able to take these vectors further, as I mentioned before, particularly at higher when we start to look at directions between vectors, angles between vectors, and pushing it on from there.